Welcome to The Explainer. Today, we're going to break down the systematic approach that engineers use to create products that are, well, truly built to last.
I mean, it's a super common frustration, right? But the difference between success and failure, it often comes down to a proactive philosophy, not just plain old luck.
And this is what makes it happen. This is the robust design process. Now, I know it might look a little complicated, but just think of it as a roadmap. It's a structured journey that takes an idea from its earliest definition all the way to a final, optimized product that just works.
So where do you even start with all this? Well, it all kicks off with a really big shift in how you think, moving away from just finding problems to actively preventing them from ever happening in the first place.
So let's jump into the first tool in the engineering toolkit, and it's all about laying down a super solid foundation. And that foundation? It's built on one simple but absolutely critical idea. Every complex project needs a single, undisputed source of information, a single source of truth.
I mean, think about it. When your teams are all working from different sets of information, from different blueprints, mistakes aren't just possible, they're pretty much guaranteed.
So what's the fix? Well, it's all about an integrated system. We're talking about things like PLM, that's Product Lifecycle Management, and PDM, Product Data Management. These platforms basically become the central brain for the whole project. Everything from CAD data to project requirements to the entire change history lives here, making sure everyone is on the exact same page.
Okay, so once you've got that single source of truth locked down, what's next? Well, now you can start proactively hunting for problems before they ever see the light of day.
And one of the coolest tools for this is something called DFMEA. It's basically a structured way to ask, hey, what are all the ways this could possibly go wrong? And you do it all on paper, where making a change is cheap and easy.
But here's where it gets really clever. This isn't just guesswork. The process actually quantifies the risk. See, potential failures get a score. It's called a risk priority number, or RPN. This is huge because it lets teams rank every single potential issue and focus their energy on the big ones first.
Let me show you a real-world example. Take a look at this lever. Before even one of these was physically made, the DFMEA process flagged it as a high-risk component.
And check this out. By making some smart engineering changes, trying new materials, tweaking the design, the team absolutely crushed that risk score. They took it from a scary 180 all the way down to a much more manageable 45. And it's not a one-off thing. We see the exact same principle with this gearbox, where the risk was cut by more than 75%. This is what being proactive is all about. You're stopping huge, expensive problems before they ever even have a chance to start.
Okay, but here's a crucial point. Robust design isn't just about dodging bullets. It's also about actively looking for ways to maximize value.
And a lot of this magic happens in these things called VA/VE workshops. That stands for Value Analysis and Value Engineering. Basically, teams get together and pull apart every single piece of a design to see if they can get the same function for less cost, or maybe even add more value for the same cost. Okay, check out this connector tongue, for example. A tiny little design tweak. They added a rib and made it just a bit thicker, and boom, the number of failures during stress testing just plummeted. A super simple change with a massive impact on durability.
So what happens when you start putting all these tools together? When it's not just one thing, but a whole strategy? Well, the payoff is absolutely huge. And even better, the benefits actually start to build on each other over time.
First up, a 30% cut in the engineering change cycle time. Now, what does that actually mean? It means the team can iterate faster, solve problems way quicker, and get to a better design in way less time. That's a serious competitive edge.
Then you've got this, 25% fewer late engineering change notices. This is the proof in the pudding, right? It shows that the proactive approach is actually working. They're catching stuff early, instead of scrambling at the last minute.
And this might be the most impressive of all. Zero. Zero lost documents during a big customer audit. Remember that single source of truth we talked about? This is it in action. Everything is secure, it's traceable, it's compliant. That is a massive weight off everyone's shoulders.
So the real magic here, the key takeaway, is that this stuff compounds. The knowledge you gain from one project doesn't just disappear, it gets captured, turned into a template, and makes the next one even better right from day one.
It all creates this incredible, powerful feedback loop, this virtuous cycle. You integrate the tools early,
You validate everything with real data, and then you embed those lessons learned for the next time. And that is how you get to sustained success and zero defect launches.
So the real takeaway here isn't just for engineers. This mindset can be applied to pretty much any kind of work. It really makes you think, doesn't it? What are the failure modes in our own projects, in our own processes, that we could prevent just by thinking this way from the very beginning?